Hey, this is Psych. Welcome back to my channel. It's actually pretty cold outside today. There's snow on the ground and so forth. But I thought I would go ahead and make a video about truth and classical test theory. So, what is truth in classical test theory? And the concept of truth, or the way that we talk and think about truth, is a bit misleading compared to how most people think about truth. So stay tuned and we're going to talk about it. Classical test theory begins with what seems to be a very simple equation. We have x equals t plus e. This equation states that x, which is my observed score, it's the score that I can see, is composed of t, a true score, and e, which stands for error. So, what is a true score? Now, I pulled this example from a textbook that I read a few years ago about measurement error in the physical sciences. So, a carpenter is asked a question. And the question that they're asked is, what is the exact height of a door? The carpenter may begin with a tape measure and find that the door is, let's say, 213.36 centimeters in length. However, is this the exact height? Maybe the door is 213.361 centimeters. How do we know? So let's assume that our carpenter becomes obsessed with this problem. Now the carpenter is going to use what's called a laser interferometer, which actually is going to use the wavelength of light in order to get an estimate. But this is also going to be problematic because it's limited. So what do we conclude, or what should we conclude? And I don't usually read quotes from a book, but I think that this is a quote that is worth reading. As our carpenter strives for greater precision, he will encounter an important problem of principle. He will certainly find that the height is different in different places. Even in one place, he will find that the height varies if the temperature and humidity vary, or even if he accidentally rubs off a thin layer of dirt. In other words, he will find that there's no such thing as the exact height of a door. I don't know what you think about this quote, but when I first read this, it was ultimately kind of like a paradigm shift. So let's say that the carpenter measures the height at one location and they find that it is X centimeters. They repeat this procedure, and then the number that they find is going to vary by some decimal point, Y centimeters. Let's assume that they repeat the procedure again, and once again, the number is going to vary by some decimal point, Z centimeters. And they repeat this process, say, a very large number of times. And each time they repeat this process, they write down the scores. Now, let's say that we're going to plot these scores. We want to put the scores on some kind of figure or chart. What would these scores look like? Well, you may have guessed it, but we would see something like a normal distribution. In fact, we would see a normal distribution. And what would be if this is our distribution of the scores of the different heights that we've collected, that we've measured, and so forth? What would be our best estimate of the exact height? Well, our best guess is going to be the average of this distribution. This is what we call a true score. A true score is an expected value after repeated replications of a measurement procedure. So with respect to, let's say, an educational or psychological test, this is going to be the student's expected score on, say, such a test if they were repeatedly tested an infinite number of times. We have this definition of a true score. We can say something about what a true score is not. So a true score, like I said, is merely an expected value after repeated replications of a measurement procedure. Now with people, the true score is going to be quite, let's say, theoretical. We can't actually test someone an infinite number of times and so forth. But we can say, and we can still get an estimate of it, we can talk about that in a different video. But we can also see that if a true score is just an expected value, then it's not a construct score. If it were a construct score, then we would ultimately confound reliability and validity. But I'm going to save that topic for a different video. So now I would like to thank you for watching, and please stay tuned for more content.